Determine the output for each of the following program segments. Assume that X and Y have the following assignments prior to execution for each statement. All right, so we have, if X is less than Y, see out sum X and Y, else see out difference X and Y. So if this little code block were to run, what would happen? Why would it do X minus Y? Correct, because it says X is 5, Y is 1, so is 5 less than 1? No, 5 is not less than 1. So 5 is not less than 1, so it skips this line, skips it altogether, jumps to the else. So it's going to run whatever the else is, so it would output difference of X and Y equals, and this would actually do the computation, 5 minus 1 is 4. All right, how about the next block? If X is greater than Y, what's that symbol? That's and, that's the and symbol. 2X minus Y double equals 9. All right, so what will it run? Yep. It's going to run the sum this time because 5 is bigger than 1 and 2 times 5 minus 1 happens to be 9. Works out perfectly. So this time it's going to say sum X and Y equals 6. What's it do with this else, see out, different? What's it do with that stuff? Skips it. Doesn't do anything at all. Skips right over it. Doesn't even look at it. All right. We still have, for part C, X equals 5 and Y equals 1. If X is less than Y, and then what's that? What's that symbol? Or. That's or. So if X is less than 5, or 2X minus 1 equals 11. Which ones are going to run this time? Difference. Why difference this time?
Because neither one of the
Neither one is true. Is 5 less than 1? No. Does 2 times 5 minus 1 equal 11? No. So neither one of these is true. They are both false. So it skips this one, goes to the else. It's going to print the difference again. Being lazy, I'm not going to write it all out. It runs the difference line. All right. Number 6. Determine the output for each of the following. X is 3, Y equals 7. We have, if X is less than or equal to 3, see out X plus Y, end line, and then see out X minus Y, end line. All right, so what's that going to do? It will do both. How come? The last one is outside of the if statement. So this line, it wouldn't matter what the value of X is. It's going to run this line either way. How do you know this line is out of the if statement? All right, there's one indication, which is indentation. And the end line really doesn't have anything to do with it. The end line is just a print, tells it to jump to the next line. So when you type things and you write if statements, the computer is going to automatically indent it for you to show you what it thinks is inside the if statement. And then when you go to the next line, it's going to outdent it to show you it's no longer. What if I wanted both of these things to be inside of the if statement? Okay, I heard brackets, I heard braces. The curly ones, that's correct. It's got to be the curly ones if I wanted them both inside. All right, so what's this one going to do? Is X less than or equal to 3? Yes, so it's going to run this line, 10, And then it doesn't matter what the if statement is. This is not part of the if statement at all. It's going to run that line, and it's going to write -4. All right, so notice that's very different from the next block. The next block says if x is less than or equal to 3, see out the sum, else see out the difference. Which, if either, is that one going to do? That one's going to do only the first one. Because again, this is true, it's going to skip the else altogether. So that one's only going to write 10. All right. Consider the following program sequence. CL, enter a value for x. What's that do? Prints to the screen, tells the user what they're going to do. Cin x, what does that line do? Lets the user type a number in. Then same thing here. Cout gives directions. Cin lets the person type in a number. If x is greater than 0, if y is greater than 0, y minus minus. Else x plus plus. All right, so there are several questions. Question A, are there any syntax errors? What's a syntax error?
Syntax is how you word a sentence. Therefore, a syntax error is where you put in something X. Like, would that be a syntax error because the value for X is put in X? Therefore, it cannot tell if X is greater than 0 because it just says X. And it doesn't know if X is greater than or less than 0.
Well, but think about what's going to happen when this program runs. When this program runs, it's going to tell the user, enter a value for x. Then the user is going to type in a number. The user might type in 10, the user might type in -50. We don't know what the user is going to type in, but they will type in a number. So there will be a number in there for x when it gets down to this line.
And a syntax error that the mom is running into, as I mentioned before, like when people type in A-U-G for August rather than 08.
Okay. So a syntax error is exactly that. A syntax error is something that you type in that's wrong. Correct. There is a syntax error, and it's one that a lot of you are making, and it's a very common one. It's very easy to do. It's very easy to forget to put a semicolon right there. So I think that's a syntax error. All right, so now that's a good question. And I think that's questions B and C. So first off, are there any syntax errors? Yes, I think that semicolon's one. Andy. Or Alex, I'm sorry.
No, if x is greater than 0, there should be parentheses if x is greater than 0.
Ah, there's another syntax error. Right here, if x is greater than 0, there should be parentheses around it. Stephen?
The y is
Same with the y's. Yes. Parentheses. All right, again, that's a very simple mistake to make. Very easy. Anytime you put the word if, there's going to be parentheses right behind it. Any other syntax errors?
Should these be separated by or statements? Because they have one else statement to follow.
In C++, we don't use the word or. We use the symbol or.
Yeah. Should we use that between the two if statements because there's one else statement?
No, I don't think so. So a good question would be, what does that else statement go with? It goes with the first if statement. And again, you can tell by indentation. This if is indented the same amount as that else. And that's a good indication that these go together. So this else is only going to happen when this is false. That's when the else will run. All right, so I think that answers question C. Assuming any syntax errors are corrected, when will x be incremented? Incremented, that's a fancy word. What does that mean? increased by 1. That's correct. All right, so if this block of code runs, the person enters the number for X, they enter a number for Y, when will we get to the point where 1 is added to the number X? Close. The opposite of that. If they type in a number greater than 0, then this part's going to run, isn't it? When is X going to get made bigger? When somebody types in a number X less than or equal to 0. So the answer for C is whenever X is less than or equal to 0. In part B, when will Y be decremented, which means made smaller by 1? So when will this line right here run? What has to happen for that Y minus minus to actually run? First off, X has to be greater than 0 to get inside the first if loop. And then Y also has to be greater than 0 to get into that if statement too. So in order for Y to be changed, two things have to happen. X has to be greater than 0 and Y has to be greater than 0. So instead of having a double if statement like this one, it could have been written as a single if statement. If X is greater than 0 and Y is greater than 0, then that'll happen. But then it would change this answer too, wouldn't it? So apparently we wanted it this way. So we wanted it to, if X is greater than 0, do stuff. If X is not greater than 0, do other stuff. So. All right, finally, on this sheet. Number 8, explain the difference between those two lines of code. If any. Maybe they're exactly the same. Okay. So for the first one, when would S have 1 added to it? What would have to happen? Michael, Michael. Or both, right? So if X happened to be a positive number, S would get 1 added to it. If Y was a positive number, S would get 1 added to it. If both were positive, what would happen? It would get added 1 there and added 1 more there, so you'd get 2. All right, how about the second line? When does S get a value added to it? Just for all right, so the first one, you're exactly right. So this one, S is increased if X is greater than 0. But what if X isn't bigger than 0? Then it goes to the else statement and so or if X is less than 0 and Y is greater than 0. For the second code, how much bigger could S possibly get? It could only get 1 bigger, couldn't it? At most. Because either X is positive or X is negative. So if X is positive, it gets increased by 1. If X is negative and Y happens to be positive, then it gets increased by 1. What if both X and Y are negative? It doesn't get increased at all. Where this one, if X is positive, it's going to get increased by 1. If X is not positive, but Y is positive, it's going to get increased by 1. But if both X and Y are positive, it's going to get increased by 2. So there's the biggest difference with this one. This one, S could possibly be increased by 2. This one, the most S can be increased by is only 1. Questions on that? All right, we're going to write a little program here. If I'm going to write a little program, how do I start? First thing I write is documentation. This program will tell a person their grade based on their average. What comes after documentation? Pound, include, aisle stream. What comes next? Using namespace std. Void main. Void main. Well, I certainly need a variable. And what's that variable going to do? Actually, this program is going to be really simple. It's not even going to find the average for you. You're going to have to find the average first, and you're just going to type in the average, which is kind of silly. I mean, it would be easier to make a chart than a program. That's correct. It certainly would be. But I want to show you the difference between parallel if statements and nested if statements, and this is a good way to do it. So what do we need for a variable? A variable called average. Is average a float or an int? Probably a float, because people could put in a decimal. 82.3 could be an average. All right. So we need one variable called, we need a variable float. And we're going to call it average. Okay. What do I need next? What do I need A, B, and C for? All I'm going to do is see out the grade, right? You're going to tell me your average is 82.3, and the computer's going to tell you that's a B minus. It's a B minus. So yeah, the person's not going to enter their grade at all. The program's just going to spit out their grade for them. I think I need directions to tell the person to enter the grade, yeah.
So you write CO, and then you would put the 2 less than sign.
So see out, 2 less than signs.
And then you would put parentheses.
Quote, you mean?
Yeah. And then you would write the directions. So enter your average.
You enter your average.
And then you would tell them how much.
Okay. If I tell you to enter your average, how could you enter it wrong?
Well,
What do I need to worry about?
if someone already knows their letter grade and they put A in, it's not going to run.
That's true. Enter your numerical average. And I being the computer, will tell you your grade. And end line at the end there. Catherine, did you have a question?
Don't you have to, wouldn't you want us to, I'm not sure, well, wouldn't you have to know how many grades you're dealing with and, you know, like how the user education better that like the average and then
No. This is a really silly program. So to run this program, first you have to get your calculator out, and you have to figure out all that stuff on your calculator and give me the average. This program isn't going to figure the average for you.
it's just going to translate the numerical average into
A letter grade.
a letter average.
Yep, that's all it's going to do. So it would be easier to just have a chart. I agree.
Would you need to enter the average range yourself? Like if you're 95
In the
to
if
100 would be A plus?
Yeah, probably I should, but again, that's more complicated than I really intend. So in the program itself, the programmer is going to decide what counts as an A, what counts as a B, so on and so forth.
Yeah, that's what I mean. Like if it's 90 to 100, that's an A. So the program would have to know that if someone entered 95, that was without an A.
Correct, so that's exactly what we're going to do next. We're going to figure that out. So what comes next after I told the person to enter their average? CN average. All right, so the person typed in their average. Now I'm ready to tell them what their grade is. So I need an if statement, or statements perhaps. So what's the first if statement going to say? And I tell you right now that 93 or higher is an A.
I would start the other way.
You want to start the other way?
Because then if it's over 100, you know what I mean?
Okay. So you want to start with the F's? See, I like to start with the good news, not the bad news.
Less
Then you end up
than
at
605, CL.
Okay.
Got that.
So what would be more efficient to start from the top? Let me ask this question. I'll go with the students.
These students are wonderful. That's why I wanted to start with the A's. But
I like bad news first.
all right, so we'll start with the F's then.
Will the program run faster if the average you entered falls into the very first one?
Depends on how you code it, and we'll talk about that when we're all done here. So I'm going to write if, and we're going to start with the bad news. We decided. So if average is less than 60. So in this class, it's less than 60 to get an F. So if average is less than 60, what's the computer going to tell you? See out. Yeah. Okay, what comes next? To get a C in this class, your grade needs to be between 70 and 77. So what should I write next? Another F. And what's that F going to say?
Average is greater than 60, but less than 70.
Okay. So we're going to write if average is greater than or equal to 60. Okay. And
Just 60 counts as the next letter grade, 60 counts
60 counts as a D. So if your average is 59.8, you get an F. If your average is 60, you get a D.
Remember,
But D's,
C.
D's get degrees, but D's do not transfer. So
Right.
you will have the pleasure of taking this class again if you get a D. And what else do I need? Average is less than 78. See out. D. Okay. What happens next? Oh, that's not. Oh no, that's not. Oh, that's a bad teacher there. D's go from 60 to 70, not 60 all the way to 78. Change that to a 70. Tough class. All right, to make this a little bit easier, we're going to skip all the plus and minus grades, just because I don't want to write that many lines. So you can go home and you can practice and you can write all this. So the next one would be if average is greater than or equal to 70 and average is less than 80. So those are your C's. Two more to go. If average is greater than or equal to 80 and average is less than 90, then you get a B. And finally, if average is greater than or equal to 90, you get an A. And then curly bracket to end the program.
So if you run this program for time, plug in 50,
If you run this program the first time you plug in 50, it's going to say F.
and then the second time you plug in 100, is there going to be a difference in response time?
No, it will be exactly the same.
It's going to run through every one of it.
Because it has to run through every single one of those, doesn't it?
Okay, so the order really is not it.
So the order really makes no difference.
I figured once you got the first one, since the server just said, okay, done.
Okay, so these if statements that we wrote, these are called parallel if statements. This is sloppy programming because of what William just said. What William just said is, if my average is 50, it tests it here. It says if average is less than 60, it has to test it. And then it has to test it again. And then it has to test it again. It doesn't matter what grade I put in, the computer is going to have to test it 1, 2, 3, 4, 5 times. Sloppy programming is actually slow. And those are called parallel if statements. In general, you want to avoid parallel if statements. They're a bad idea. They make your program run slow. Again, our programs are going to be pretty small. If I run this program and then I run the one I'm going to write in just a second, am I actually going to notice the difference in speed? No, because our programs are so short. But when your programs start to get to be tens of thousands of lines, when you do real programming, then things like this do start to matter, and it does start to slow down your computer. Okay, so I'm going to rewrite this program. I'm not going to rewrite the whole program. I'm just going to rewrite it starting from here. The rest of it's exactly the same. So we still have to have all of the documentation, the include, the using, the void main, define the variable, tell the person to type in the variable, and then we get it. Here's the way we should write those if statements, and these are called nested. We would do this. If average is less than 60, see out, see out F. Else. I don't know why I put the curly brackets. I didn't really need them, but I did. Else. Now I need the curly brackets. If average is less than 70. See out. D. All right, so right now let's think about it for a minute. What if just this block so far, it runs and somebody types in my average is 52. It's going to say F, and then what's it going to do? It's going to skip the else line. It's going to skip all the rest of it. It doesn't need to check it, so it's going to run quickly, isn't it? It only needs to test once. On the other hand, what if somebody runs this and they type in that their average is 65? Is 65 less than 60? No. So then it goes to the else if average is less than 70. So do I need to tell it once again to check to see if average is less than 60? So I don't need that and part anymore, do I? Because I've already said, if average is less than 60, do something. The only way it gets to here is if average is already a number bigger than 60. So I don't need to put average is greater than or equal to 60 and average less than 70. I've already taken care of that less than 60 part. That's all done.
How many else's can you make on? Like, can you just keep writing else if average less than 8?
Absolutely, and that's exactly what I'm going to do. So my very next one is going to be,
If all statements are candidates, I am.
right,
Nesting.
and that's why they're called nested if statements. So first we have the first if. The first if tests to see if it's less than 60. If it's not less than 60, it goes to here, it tests to see if it's less than 70. What if it's not less than 70? I need an else. And then what do I need to test? If it's less than 80. So else, I need another curly bracket. Oh, I know I didn't close the first one yet because I'm not done with the first one. Yeah, they're going to be nested. They're all going to close at the end. If average is less than 80, see out. That would be a C. And then, semicolon. I almost forgot. Keep going, right? Next one is else. Another curly bracket. If average is less than 90, see out. B, else, see out A. I don't even need to test the last one. Because how's the only way it can get to tell me that it's an A? If I pick a number greater than or equal to 90, what's going to happen? If the number is greater than 90, is it less than 60? No, so it goes to the else. Is it less than 70? No, so it goes to the else. Is it less than 80? No, so it goes to the else. Is it less than 90? So the only choice is, it has to be bigger than 90. If it's bigger than 90, then I earn an A. All right, now you did notice that I need to match my curly brackets, don't I? All right, so this curly bracket, I already matched with that one. So then I have 1, 2, 3 left curly brackets, which means I need 3 right ones. And again, when you do this, and you type these in, the computer's going to indent them and outdent them like I did. So when you put the first else and you put a curly bracket, it's going to indent the F, and then the next curly bracket will be indented further for the else, and the next curly bracket. And so keeping track of the curly brackets isn't as hard as you think, because you can see up and down if they're lining up and what curly bracket goes with what curly bracket. All right, so that coding is much more efficient, because the only time it has to test 5 things is when you get an A. If your grade is a C, it does this if, it does that if, it does this one, and then it's done. So if your grade's a C, it only has to test 3 things, where with this one, no matter what you put in, it had to test 5 things. Or even worse, it had to test more than 5, because it had to test, for most of these if statements, it had to test 2 things. So it had to test a lot more than 5. It had to test 1, 2, 3, 4, 5, 6, 7, 8 things every time. This one, at most, will have to test 5. And the only time it will have to test 5 is when you get an A. Otherwise, it'll test less. So, in general, try to avoid parallel if statements. Try to do nested ones when you can. It's much more efficient coding. It's a little harder to read, and it takes a little while to get used to it, though. But once you do this a few times, you'll get used to that I don't need to test everything at every step. I go down the line like so. Questions on the difference between parallel if statements versus nested if statements?
You can run nested, but it not be more efficient, but most effective.
Yes.
That's why I asked whether or not
So yes, absolutely. So if I thought most of my students were going to get an A, it would be better to flip this and start with if average is greater than or equal to 90, and then my next one would be if average is greater than or equal to 80, so on and so forth. So yes, if you have expected values, it would be in your best interest to order those in that expected, and then your program would run even faster. Absolutely. So this does not indicate my expectations of this class. Other questions? Well, that wasn't very nice. He said this meets his expectations of Nick. And I said that was. What are friends for? Other questions, comments, concerns?
First curly bracket way up the top.
Yeah, I didn't need that one.
Okay, so there's only one.
I got excited about curly brackets because I knew I was going to need them. But I only need them to nest the else's. I don't need them because this if only does one thing if it's true. Yeah, I got curly bracket happy. Nothing wrong with putting extra curly brackets in. Again, it makes your code harder to read when you start getting curly brackets all over the place when you don't need them. Other questions?